Hi friends, welcome back to the next lecture. In the previous lecture, we have discussed sorting techniques, and in today's lecture, we try to understand basic searching techniques. There are two basic searching techniques. One is called as linear search and binary search. So let us understand linear and binary search one by one. So we'll start with a linear search algorithm. So let me take an example. Yeah. So friends, we'll start our discussion with linear search. So linear, the name itself says we are going to search element by element. So again, the concept is very simple. It is related to arrays because when I am searching for an element, it means that I am dealing with multiple elements or many elements. In that, I would like to search for something. Yeah. So let me take an example like imagine I have an array of size 7 or 8 elements, whatever it is. So imagine this is my array, friends. So 10, 15, 20, 25, 30, 40, 50. So how many elements are there in my array? One, 2, 3, 4, 5, 6, 7 elements are there in my array, right? So this is zeroth position. This is 0, 1, 2, 3, 4, 5, sixth position, right? So array index, I'm talking about array index. So if you look at the array index, the first element is the zeroth element and the last element is n minus 1, which is sixth element. So if I call this one as an array a of 6, and probably this is a of 0, right? So I hope you understand the array indexing concept. So a of 1, a of 2, a of 3, a of 4, a of 5, and a of 6. So friends, what we do in a linear search algorithm, in linear search algorithm, we will ask the user to enter the array elements. So first we will ask the user to enter what is the size of the array. Then we will ask the user to enter the array size, array size. Then we'll ask the user to enter the array elements. And once the user has entered the array elements, then again we will ask user like what is the element he is searching for. So let the user enter an element which he wants to search, and imagine user wants to search for an element called as maybe 55. So I'll store that user input in a variable called as x. So friends, x is equal to 55. So what I am searching for? I am searching for an element called as 55. So I would like to know whether this 55 is present in this array or not. So I would like to understand whether 55 is present in this array or not. So what we do in linear search is we will compare x with a of 0. If the element found is same as the element which I am looking for, then my job is done. I can say element is found at 0th position or first position, right? If I talk in terms of array indexing, I call it as 0th position, or else I can add 1 to that index and I can say first element is matching with the required element. So I compare x with a of 0. If it is not matching, I will compare x with a of 1. If it is not matching with a of 1, I will continue comparison till the last element. So x will be compared with 10, 15, 20, 25, 30, 40, 50, and finally I came to know that 55 is not present in the array. So if the element is not found, I'll simply say that the element is not found in the array. So friends, this is what a simple linear search algorithm is. So linear search is a very simple technique and it is easy to implement. But the problem is if you observe, if I have 1 lakh elements in my array, please try to understand, if I have 1 lakh elements in my array and I want to search for a particular element called as x, Now imagine if that x value is not present in the array. If it is not present in the array, when I will come to know that it is not present in the array, right? When I come to know that it is not present in the array, only after doing 1 lakh comparisons, only after doing 1 lakh comparisons. So this is not a great approach, or this seems to be not a better technique. So friends, that's the reason we need to go for some other better searching technique. So in linear search, the advantage is it is simple. Linear search is a simple technique. Linear search is easy to implement, but linear search is easy to implement. Linear search is simple, but at the same time, linear search is not cost effective. So here, what do you mean by cost? Cost means the time. So it will take a lot of time because one by one, serially, sequentially, we are doing comparison. So it's going to take a lot of time. That's the reason linear search is not considered to be a great searching technique. So friends, let us try to see the program. Let us try to understand the code. Then we will come back and we will discuss another important algorithm or another important search technique called as binary search. Yeah. So it's very simple. Uh, Implementation is quite simple. Void main int a of 10. I've taken a couple of variables for my iterations and other requirement. So I'm asking user to enter some array elements. Again, as I told you, I don't want to complicate my program. So I wanted to keep things simple. So I'm using a static memory concept. I'm using an array of size 10. So I'm expecting user to enter elements which are less than or equal to 10. So I ask user to enter the number of elements first. So user will enter his choice in n. So maybe 5, 6, 7, something like that. Then I'll run a loop to collect those n number of values. So if user says he want to enter 5 values, I would like to collect those 5 inputs in an array called as A, right? So now, after that, I'll ask user what is the element which he wanted to search. I am collecting that search element in a variable called as x, very much similar to what we have discussed just now. Then I am running a simple for loop n number of times to compare each and every element, to compare x with the first element, second element, like that till I find x. If the x is not found in the array, I'll simply say element not found in the array. Suppose if x is found in the array, I'll print the location and I'll come out of my program. The reason why I come out of my program using exit function is once the element is found somewhere in the array, I need not search in the remaining portion of the array. So I intentionally I would like to come out of my program. Now if you observe, suppose the element which I am searching is not there in the array, then this if condition will never become true. If x is double equal to a of I, this will never become true if the element which I am searching is not present in the array. Then what will happen? That exit will also never execute, and straight away I'll come out of the for loop, and after coming out of the for loop, there is a print statement like element not found in the array. So friends, the logic is simple. If the element is found within the array, I am going to quit or come out of my program. If the element does not found, I'll come out of the loop and print a statement like element not found in the array. So it's a very simple program. So let me run this one for your convenience. So it's asking number of elements. So let me enter number of elements are 6. What are the elements which you want to enter, like 66, 88, probably 99, then 54, maybe 32, right, 22. Then it is asking what element you would like to search. I am searching for something called as 54. 54 found at location number 4 in the array, right? So this is how a simple linear search algorithm will run. And linear search, as I told you, it is simple, it is easy to implement, but it is not a great searching technique. It is not cost effective because it is going to do a lot of comparisons. So we would like to go for a better algorithm, better searching technique called as binary search. and let us try to understand how binary search actually works and how binary search is a better algorithm or a better technique than linear search, and how do we actually implement it. So let me go back. Yeah, so friends, the algorithm is what is the algorithm? Algorithm is binary search. So in binary search, again, I have some array of elements. I want to search for a particular element in the array, and I would like to do a better searching when compared to linear search. I want to search the element quickly, right? So let us assume like this is my example array. Let us assume I would like to take an array of some maybe 9 elements, something like this. So my array elements are 99, then 66, 44, 33, 22. So there are 5 elements. So I thought I'll be taking more than that. So I'll take 11, then maybe 49 here. So 49, 99, 66, 44, 33, 22, 11, 4, 5, 6. Total 7 elements I have taken. So let me take 7 elements as my array. Now what we do in binary search? In binary search, the step 1 is you have to sort the array. So friends, this is not present in linear search, right? In linear search, right from the beginning, we were searching each and every, we were comparing each and every element with the exact search element which we were actually searching, right? So for example, again in this case, I would like to, maybe I would like to search for 11. So this is my search element. My array is 49, 99, 66, 44, 33, 22, 11. So friends, step 1 in binary search is you have to sort the array. That is the first step. So you can apply either insertion sort, selection sort, or bubble sort, whatever sorting technique is comfortable for you. You can apply any one of the sorting technique. And if you observe, we have already discussed sorting algorithms in one of our previous class, right? So if you have not gone through those three sorting algorithms, you can refer my video lecture on sorting algorithms. So friends, so step 1 in binary search is sort the array. So what will happen after sorting? So my array will look like this. So 11, 22, 33, then I think it's 44, right? 44, then 40, sorry, 44, 49, then it is 66, then 99. So this is my sorted array, friends. So step 1 in binary search is you have to sort the array. I have sorted my array using any one of the searching technique. So what is the search element? What I am actually searching for? I am searching for 11, right? So friends, in linear search, we were searching in a serial order, right? So maybe you think that in binary search, again, with if I compare it with my first element, probably I can easily get that element. But okay, what I'll do is I'll not take 11 to explain you the importance of binary search. Instead of 11, I'll take something else, because if I take 11, then you may think that linear search is a better option, because in linear search you can get it immediately in the first comparison, whereas in binary search probably you may not get it in the very first comparison. So what I'll do is I'll change my x value, for my convenience. To make this example little simple, what I'll do is instead of 11, let me take x value as uh, 99. Imagine I want to search for 99. So what we do in binary search is first we will sort the array, then we will take the middle element of this array. So what is the middle element? How many elements we have? We have total 7 elements. 7 by 2 is 3.5, but in integer division 3.5 will give you a result of 3. Means This is my zeroth element. This is my first element. This is my second element. This is my third element. This is my fourth element, fifth element, sixth element. Actually, seven elements, but I am counting from zero because index is zero. So the zeroth element is 11 and the last element is 99. So friends, if I do 7 by 2, or the middle element which I am going to get is, middle element is 44. So what I'll do is I'll compare x with 44. If x, the element which I am searching, is same as my middle element, I got my element, I need not do anything else. Got it? So what is x? X is 99. 99 and 44 are same, they are not same. But friends, 99 is greater than 44. So what do you understand by that? What do you understand by that? Since the array is already sorted, now there is no chance like 99 I can get in the left half of the array. So if 44 is the middle element, this part is called as, this part is the left half. Yes or no? This is the left half and this is the right half. So friends, it's very clear. I know very well, like, array is already sorted and the element which I am searching is not equal to the middle of the element, and it is greater than the middle of the element. When it is greater than the middle of the element, it means like I need to search for that element in the right side of my array. I need not consider the left half of the given array. So straight away 50% of my comparisons are reduced, whereas in linear search I would have compared all those elements with my x. So that's the difference between linear search and binary search. Straight away half of my elements, half of my comparisons are reduced. Now what I'll do is, where I need to search now, 99 is greater than 44, means already comparison with 44 is done. Left half is not required. So what I am left with, I need to search for 99 in the right half. So friends, what will happen is, now my latest array in which I need to search is only the right half, 49, 66, 99. So what we do on this new array is, again we will apply our binary search logic once again on this particular array. Means I am going to use the concept of recursion. I continue to divide this array by searching for the middle element, comparing x with the middle element, and if the x is greater than or less than or equal to that middle element, accordingly the left half or the right half will be considered, and this process continues till I find the element, or till I don't find anything, a required element in the array. So friends, what will happen in the second step? Since 44 is less than 99, it is very clear, like, 99 should be there in the right half of the array. Maybe it may or may not be there, but if at all it is there, it should be in the right side only. There is no chance of 99 to be found in the left half. That is the reason I need not consider the left half, and the middle element is also already compared. So I am supposed to consider only the right half, which is only three elements, 49, 66 and 99. Now friends, what will happen? Again I will apply binary search logic. Again I will try to see what is the middle element in this new array. What is the middle element? 66 is the middle element. So what I will do, I will compare 66 with x. Whether 66 and x is same, if they are same, I got my required element. But if it is not same, then I need to check what is x and what is the middle element. Yes, x is greater than middle element. So what do you understand by that? X is greater than middle element, so I need to ignore the left half as well as the middle element. I need to consider only the right side of the middle element. So what is right side of the middle element? This is right side of the middle element. And what is left in the right side of the middle element? We have only one element. What is that one element? 99. So in the next step, what I am left with? I am left with only one element. Now what we will do, we will compare this one element with our x, and x equal to 99. So I'll say I got x in so and so place. I found x straight away. So friend, how many number of comparisons we have done? If it is a linear search, right, maybe I need to do n number of comparisons. Suppose if the required element is not there in the array, I will be doing n number of comparisons. Imagine if there are 1 lakh elements, and if the required element or if the search element is not there in the array, I will come to know that the search element is not there in the array only after doing 1 lakh comparisons. That is the problem with linear search. Whereas in binary search, for example, I have 1 lakh elements. I'll compare the search element with the middle element, and if the search element is greater than middle element, I'll go to right side of my middle element. Means straight away the left half is removed. I need not consider because they are already sorted. So since they are sorted and my search element is greater than middle, it means that the search element should be there. If at all it is there, it should be there on the right side of the middle element. So I will straight away, I am able to prevent half of the comparisons. I am able to avoid 50% of the comparisons, and then in the next half again I repeat this process. So what will happen is, if by repeatedly recursively applying this concept of binary search algorithm, where we try to divide the array into two halves and compare search element with the middle element. So if I recursively do this process, within less number of comparisons, I'll come to know whether the given search element is found in the array or not. If it is not there, quickly, maybe if, even if I have 1 lakh elements, maybe if the search element is not there in the array, in linear search, I'll come to know that after doing 1 lakh comparisons. Whereas in binary search, I probably maybe less than 100 or 100, 150, 200, very less number of comparisons, hardly less than 200 number of comparisons probably. It all depends on what exactly are the elements in the array, but definitely it is not going to take 1 lakh comparisons. It will be only in few hundreds or even less than that. So that is the benefit of binary search, and that is the beauty of binary search. So we continue dividing our array into two halves, left and right, and depending upon the search element, either I'll pick left and I'll ignore right, or I'll pick the right side of the array and ignore left side of the array. It all depends on the middle element and how the search element is compared with middle element. If search element and middle element are same, element is found, you need not go here and there. If search element is greater than middle element, then you have to go to right side of the array. If search element is less than the middle element, you have to go to left side of the array. So I hope the binary search algorithm is clear to everyone. So let me show you the program for binary search. Friends, all these programs are self-explanatory. If you understand the concept, the code will be very simple, and the codes were already shared with you in our regular class. So this is the program to implement binary search. So I have written a separate function called as binary search, and if you observe, I am passing four parameters to that binary search function. So the first parameter to that binary search function, my first parameter to the binary search function is the array itself, means the array on which I am doing my searching, and LRX. L means the lower index, R means the upper index, or you can say left, right, and X is the element which I am searching. Now try to understand the signature or prototype of the binary search function. In this binary search function, we are going to return an integer, right? So this function will return -1 if the element is not found in the array. If the element is found in the array, then it is going to return the position of that element, like fifth position, sixth position, 10th position, like that. But if the element is not found in the array, it is going to return -1. So please keep that point in your mind. And this is our binary search function. So what we will do is everywhere for every line we have tried to give in comments so that when you refer you can easily understand. So first we will see the main, then we will go to the function call, because from main we are actually calling the function. Yeah. Yeah, int arr of 10 xij temp, some variables we have taken. Enter number of elements, again preferably less than 10 because my array size is 10. Then I am asking user to enter the array elements. All the array elements are going into arr. Now read the input element to search in the array. Read the input element to search in the array. That I am storing in X. Now code to sort the array. So because binary search, as I told you, step one is to sort the array. This for loop, nested for loop, if you observe friends, it's a, simple selection sort logic which I have applied. So this is to sort, and sorted array is also printed. After that, see here this line, apply recursion to call binary search function. In that I am writing index is equal to binary search of arr comma 0 comma n minus 1 comma x. Please try to understand, index is a normal integer variable in which I am going to get the result of binary search function. But binary search is a recursive function. So its integer, its return type is integer. Finally, its return value I am collecting it in main. And if index is minus 1, means if binary search returns minus 1, it means element is not present in the array. Otherwise, element is present in so and so location. So index will get the position of the element if the element is really found in the array, or it will return minus 1 to say that the element is not found in the array. Now what I am passing to binary search function, first time when I am calling binary search from main, what I am passing? I am passing the array itself. So how do you pass an array to a function? Simply write the array name while calling the function, comma, what is L value? 0. What is R value? N minus 1. So if I have 7 elements as per our previous example, this first parameter will be 0 comma 6. X is the number which you are searching in the array. So parameters of binary search, I hope you understood. Now let me go to binary search function. So this is binary search function. Now what we are doing in binary search, please observe. If r is greater than or equal to 1, then I'll enter into the if condition. Yes, r is greater than or equal to 1 or not. First time what we have passed arr, comma, L value as 0, R value is n minus 1. So if I have 7 elements in my array, n minus 1 means 6 will be passed. Yeah, 6 greater than or equal to 1, then I'll enter into this if condition. I'm trying to calculate the midpoint. So what we have done in our previous discussion, we have tried to identify the middle element. Same thing we are doing. Int mid is equal to L plus R minus 1 by 2. So I'm trying to find the middle element. Now if the element is present at the middle itself, I'll return that index, return mid. Otherwise, if ARR of mid is greater than X, if ARR of mid is greater than X, X is the search element which I am actually searching for. So if the middle element is greater than X, it means that the element which I am searching should be on the left half of the array. Or if the middle element is less than, if the middle element is less than X, if the middle element is less than X, it means that the value which I am searching should be on the right side of the array. So for that purpose, what I am doing, see the first condition, if ARR of mid is greater than X, means if the middle element is greater than X, what do you mean by that? If the middle element is greater than X, it means that the X which I am searching for should be there on the left side of the array, because the middle element is already greater than X. So I need to look into left half. I need not look into right half, because right half values are, since the array is sorted, right side values are obviously greater than X, because the middle itself is greater than X. So if the middle element is greater than X, then where do I search? I need to search before the middle element, means in the left half. So what I am doing, again I am calling binary search function recursively, and what I am passing, please observe, ARR common, again I am passing the array, but see the indexes L, comma, mid minus 1. L is still 0, my dear friends. L is still 0, mid minus 1. If my middle element is, let us say, seven, out of 7 elements, if my middle element is third element, which is technically 0, 1, 2, 3, means the fourth element, right? Mid minus 1 refers to 2, 0, 1, 2. Since already with mid we have done the comparison, again mid we need not consider. So what I am doing, 0, comma, mid minus 1 is the index. It is the new array now. From the same array, I am considering only the left half, and I am passing x because I am going to search for x. So again it will go to binary search. It's a recursive call, but now the binary search is applied on the same array, but only on the portion left half of the array starting from 0 to 2. Like that, again it will enter into the function, recursive call will be done. Again it will check what is the middle element. Again it will compare the middle element with the x. If it is found, if it is matching, that index will be returned, or else again based on comparison between middle element and x, either I will take left half or right half of the array. I repeat this process till either I don't find the element in the array, or if I get the position of the element in the array. So this is what is binary search, my dear friend. So let me execute. What I suggest is you please go through this process. What in this video we have clearly explained you the process of binary search. So trace the program, then only you will understand how programs are running. Tracing is very important. Take a pen and paper, draw the variables, see what is happening in the variable, right? Then only you can understand the program. So enter number of elements in the array. Let us say I would like to enter 9 elements. What are those 9 values? So friends, I have entered the 9 elements. Now it is asking what element you want to search. I would like to search for maybe 29. So sorted array, first it is sorting the array 29, 77, 88, 99, 123, 198, 345, 567 and 64, 654, sorry. And element is present at index 0, right? So friends, let me run this again. Let me take a smaller array 5. I'm entering those 5 values 6, 77, 99, 987 and 5645. Enter the element. 5 elements I have entered. Now I am trying to search for an element called as 1000. Sorted array is 679956459876. Element is not present in the array. So friends, with binary search we are able to reduce the number of comparisons drastically, and this will be applicable if, especially when you are dealing with very large scale or large sized arrays and if there is a requirement of doing a lot of comparisons, then you can avoid comparisons. Searching can be done quickly and effectively using binary search, and it is more cost effective than conventional linear search algorithm. So friends, I hope both linear and binary search algorithms are clear to you. Once again, I am telling you, if you trace the program by using pen and paper, draw the variables in the form of small boxes and see the values, how the values are getting changed when we execute a particular instruction. Like that, if you trace the program, then it will be easy for you to understand, and only with continuous practice you can become more comfortable in programming. So I hope linear and binary search both algorithms are clear to you. And if you have not gone through the sorting algorithms video, please go through it. I have already shared a video lecture on sorting algorithms, because in order to understand binary search, you need to understand sorting algorithms also, right? Because we sort the array first, then we apply our binary search recursive function. So I hope things are clear, both linear and binary search. So I'll be sharing you one more video lecture wherein we discuss structures and how do we create structures, why do we create structures, what is the importance of structure. All those things will be discussed in the upcoming video. Thank you.